Today we're doing section 3.4 day 1 and we're discussing how to solve exponential and logarithmic equations. So the first set of examples is solving when you have a common base. So a problem like this, your objective would be to get the same base on both sides. So my common base is going to be 2, so the left side is going to stay as is, and the right side I can rewrite as 2 to the 4th. So like 4 squared is also 16, but I need the bases to be 2, and that's why we choose 2 to the 4th. Now that our bases are the same, we set our exponents equal. So the 3x minus 8 has to equal 4. I add the 8 over, and we get 12 divided by 3, and x is going to equal 4. So that's when you change one side. For letter B, we're going to have to change both sides to be a base of 3. So 27 becomes 3 to the 3rd. And notice I'm going to put the quantity of x plus 3 in parentheses. Same thing on the right side, I'll have 3 squared with this x minus 1 in parentheses. Now that I have the same basis of 3, I have set my exponents equal and I'm going to distribute that in. So I'll have 3x plus 9 equals 2x minus 2. I'm going to subtract this 2x over, and I'm going to subtract the 9 over. So I'll have x equals negative 11. Alright, so go ahead and try that practice problem. So now the next two examples are when you don't have the same base. So something at the top, it says non-common base on your paper. Right next to that, write log base A of B. So the way we would type this in the calculator is log B divided by log A. And this is called change of base, and we use this when we don't have the same base in order to solve problems. So here, 15 can never be rewritten with a base of 4, so my only option is to put this in log form. So I'm in exponential form. To put this in log form, I'll have log base 4 of 15 equals x. And notice by doing that one step, I've now isolated the x. And then this is where we're going to use this down here, the whole change of base, and you would type in the calculator log 15 divided by log 4. And when you do that, you get x equals 1.953. And we'll do some practice on typing this in the calculator tomorrow. Also, if you have a smartphone, you can use your smartphone. Most phones, you just have to turn sideways to access log. Or on your computer, you can pull up calculator, or you can type it in Google to get the answer. Same thing for this one. Put it in log form. So I have log base 10 of 120,000 equals x. We would type it in the calculator. Because calculators are base 10, you don't have to do the change of base. You can just type log 120,000, and you'll get x equals 5.079. Okay, so go ahead and try the next problem. If you don't have a way to get it as a decimal, just write it in this form down here, how you would type it in a calculator if you have one. Okay, so the last one is still going to be what we call putting it in log form. The only thing that's different is our base is e and not a number, so we're going to use natural log. I got to get the base by itself as much as possible, so I'm going to add that 3 over. So I'll have 240, divide both sides by the 40 to get e by itself, because remember e is the base. So e 0.6x equals 60. And now there's nothing else I can do. 60 can never have a base of e. So I put it in what we call log form, but because it's an e, we're going to use natural log. So natural log base e of 60 equals 0.6x. Calculators are in base e for natural log, so you don't have to do the change of base here. You just type natural log of 60. When you do that, you get 4.094 equals 0.6x. And we're going to divide both sides by 0.6. And we get x equals 6.823 repeating. Okay, so go ahead and try that last problem and make sure you input your answer on the video.